Imagine you are sound asleep in your bed at 3 a.m., and your most demanding client emails you a highly complex, messy data request. But by 3:05 a.m., a digital system has securely queried your company database, analyzed the numbers, formatted a nuanced response, and sent it back. You haven't even woken up yet. This scenario is a present-day reality, and you do not need a master's degree in computer science to set it up. Everyday people are taking control of these workflows right now without writing a single line of syntax. To master this toolkit, we must divide the modern AI landscape into two distinct functional buckets: passive problem solving, which we'll call things to use, and active custom automation, or things to build. Let's start with that first bucket. To build reliable systems, we have to understand how modern multimodal AI actually ingests our data. We are no longer dealing with simple text-in, text-out chatbots. These models process dense audio files, massive unstructured datasets, and raw images simultaneously. The AI mathematically maps visual and audio data into the exact same high-dimensional vector space as language. Acting as a digital synthesizer, it takes a messy, hour-long audio recording and instantly translates that chaos into clean, structured database columns. Understanding how models ingest and translate this raw data is the mandatory prerequisite. If you don't understand how the inputs are handled on a passive level, any complex automated system you try to build around them will fail. The models available to us break down into two distinct categories. Fast, iterative models. Think of them as your highly capable junior coworkers. Operate entirely on probabilistic token prediction. They predict the next most likely word, meaning they desperately need rigid instructions. On the other hand, reasoning models, your senior coworkers, use reinforcement learning to generate an internal chain of thought, debating themselves to navigate highly ambiguous goals. If we are relying on those fast, cheaper junior models for our daily tasks, we have to follow one strict architectural rule to force reliable outputs: the strict separation of message roles. This animated visualization details that separation. You must split your prompt into two distinct structural containers. The rigid, locked top container is the developer message. This is where you establish the unalterable rules and negative constraints for the AI, its laws of physics. The fluid bottom container is the user message. This holds your dynamic daily input, like the raw CSV data you need analyzed today. Separating these roles prevents the AI from confusing your specific behavioral instructions with the data itself, eliminating context bleed. To enforce these boundaries even further, you wrap your reference data in XML tags. These tags act as a visual guardrail for the neural network's attention heads, creating a clear syntactic boundary between static reference material and active commands. Dumping your reference data and instructions into a single block without these boundaries triggers lost-in-the-middle syndrome. The model loses track of which words are rules and which are data, resulting in confident, unusable hallucinations. But as you load up your prompt with heavy developer rules, massive XML-tagged documents, and formatting examples, you hit a massive point of friction. You risk maxing out the model's context window, its short-term memory, which generates massive latency and highly expensive API fees. The enterprise solution to this memory limit is a targeted search process known as Retrieval Augmented Generation, or RAG. This diagram illustrates the RAG mechanism. Instead of forcing the AI to read an entire set of encyclopedias every time you ask a single question, the system converts your query into a mathematical vector, searches your database for the nearest semantic neighbors, and grabs only the specific paragraphs that contain the answer to inject into the AI's context window. RAG keeps the model's attention laser-focused on a tiny subset of data, drastically cutting the computational waste of processing an entire document library. Yet, even with perfect formatting and highly efficient context windows, a different kind of friction remains. Opening a blank chat interface every single day to manually paste in your XML tags and multi-shot examples is tedious, exhausting labor. That friction is the exact catalyst for moving into our second bucket: things to build. To eliminate daily setup, we must transition away from the generic, friction-heavy Swiss Army knife of a standard chatbot and start architecting a custom toolbelt. As illustrated here, custom agents function like sleek, single-purpose tools. They permanently store your heavy developer rules and few-shot examples inside their system prompt. There is no daily setup. You just reach for the tool, and it works.
Deploying a custom Toolbelt removes the manual labor of formatting. You step completely away from repetitive typing and goes straight into executing instantaneous, pre-configured logic. Building agents on no-code platforms involves the construction of true structural logic. You aren't just designing a visual interface, you are architecting how the system thinks. By describing a business problem in plain English, these platforms provision relational database schemas, secure user authentication flows, and hard-coded database operations in seconds. You can then plug these custom agents directly into the software silos your company already uses. By giving an agent secure access to your CRM and central Notion workspace, it acts as an autonomous data analyst that your whole team can ping for real-time information. But the peak of this automation is an event-driven architecture that runs entirely in the background. The logic triggers automatically based on specific incoming payloads, like a client submitting a form or an audio file being dropped into a folder. By linking these events together via webhooks, you create a tireless digital mailroom clerk that routes raw data, extracts insights, and updates your ledgers completely hands-free while you sleep. Of course, granting an automated script direct administrative access to your private client databases raises a massive pragmatic concern. A single hallucinated output or leaked piece of proprietary data could jeopardize a key account. The solution to this risk is restricting the probabilistic AI by wrapping it in deterministic security systems, known as AI guardrails. Guardrails act as an independent interception layer between the AI's output and final action. The checkpoint scans the payload. If it spots private information, it drops the packet entirely. Furthermore, proprietary inputs are processed locally and immediately discarded, ensuring your data is never retained. Implementing strict data interception and localized processing ensures the architecture is secure. The technology matures from an experimental toy into highly reliable core infrastructure. This brings us to an unavoidable question about the future of our workflows. When AI systems translate the complex data, provision the databases, and execute every repetitive background task, what uniquely human skill remains valuable in the workplace? The friction of technical execution has effectively dropped to zero. Building secure software no longer requires writing complex syntax. In a landscape where anyone can provision a database instantly, the primary differentiator left is the specific quality of your vision. Taste is the ultimate human API. Our core professional value shifts away from manually executing code and entirely toward the orchestration of logic.